All right. I reckon I'll get started by recording, and we've got, close to 70 people. That's pretty good. So, hello everyone. I'm Rachel Montgomery. I'm the Energy Flexibility Lead at NABERS, and it's really exciting to have you all here with us to, hear about energy flexibility in commercial buildings and learn more about the launch of our feasibility study. So before I get started, I'd like to acknowledge that I'm on the lands of the Darug and Gurungai people in the northwest of Sydney and pay my respect to the elders, both past and present, who take care of this beautiful bush country that I'm so lucky to live on and have done so for thousands of years. Also, if there's any other Aboriginal people on the call today, Yama. All right, we have a pretty action-packed agenda for you. So we're going to start with some context as to what energy flexibility is, because it's a relatively new concept, although it is becoming a major topic of conversation in the industry, which we love. We're going to get into the study itself. We'll give you an overview of the report and we'll delve into some key insights. Then we're going to outline our program of work for the next 3 years. And we have a guest speaker to come in and talk about the benefits of energy flexibility, and then we'll end on some questions from you guys. So some housekeeping before we get started. You're welcome to turn your cameras on if you're comfortable. We'd love to see your smiling faces. Microphones have been muted just to reduce background noise, but when we get into the question portion, if you need to expand on a question verbally, we can unmute you in the moment. We are recording the presentation. It will be uploaded onto our YouTube afterwards, and we'll distribute the link on Monday or early next week. We'll stop the recording before we get to the question portion. You can post your questions in the Q&A section of the meeting. The chat has been turned off, so anything you want to ask, put in the Q&A section, and upvote anything that you're really keen on hearing, just so that we know what we can prioritize. If we can, we'll answer it within the Q&A as well. And then, we'll be pretty short on time. I think we'll have hopefully about 10 minutes at the end for questions. So if we don't get to all of them, we'll be able to distribute answers afterwards. And I'm sure I don't have to tell anyone this, but, please be kind and respectful with your questions. And we'll share the slides and recording after the meeting. So you're going to hear from a few different people today. In a second, I'll hand over to our director, Magali Wardle. Then you'll hear sort of throughout the presentation from myself and my colleague, Nova Franklin, who's the principal strategic designer at NABERS. And then later on, Alex Sear, the director, energy sector lead from ADP Consulting, will talk through the benefits of flexing. So without further ado, over to you, Magali.
Thank you, Rachel, and thank you to everyone who's joined us today. I'm just looking at the attendee list. We've hit the 100, so it's really great to see such a lot of interest in this subject, particularly on a Friday afternoon. So just as a quick kind of introduction to the day today, NABERS has actually been helping buildings to measure and manage their sustainability performance for over 25 years. Over this time, we've built a really strong reputation by developing rating solutions that are robust, rigorous, and meet the needs of industry and government. One thing I've been reflecting on, though, is that the sustainability ecosystem that we work in is really dynamic. And we've actually reviewed and updated our energy rating many times over the past 25 years as things have changed. For example, most recently, we've added in the renewable energy indicator, and we've committed to moving to an energy-based metric for our star rating in 2030. So in line with this theme of evolution, we're really delighted to welcome you to this webinar to mark the launch of our Energy Flexibility Feasibility Report. This is the culmination of a year of research, including talking with lots of people. So thank you to all of you who've been so generous with your time. As a result of this study, I'm really pleased to share that we now have 3 years of funding to test and develop NABERS solutions that can support energy flexibility in buildings. And Nova and Rachel are going to go into a bit more detail about what that means. This is really exciting because it enables NABERS to continue to play an important role in terms of supporting a more stable and renewable electricity grid. So as we want to enter into this next stage of work on energy flexibility, we really want to keep the conversation flowing. Our work's only as good as the information and the resources that we have. So if you can help us out, we'd love to hear from you. So now I'm going to pass back to Rachel. But yeah, great to be here today.
Great, thanks, Magali. All right, so let's get into the first section. What is energy flexibility? So Australia's grid, we need to transition to a stable grid powered by renewables, but getting there is not straightforward. So if I go to the next slide, that's because supply and demand can be misaligned. So when there's a lot of renewable generation and not enough consumer demand, renewable energy can be curtailed. That's often in the middle of the day because rooftop solar is providing all of the power that people need. It's also particularly spring and autumn when there's lots of sun and wind, but not much need for heating and cooling. It means we're wasting valuable renewable resources, and at its most extreme, it could even push the system below its minimum safe level of energy use, which risks stability, and it could damage the infrastructure that we use to keep everything running. Then on the next slide, when renewable generation is low and consumer demand is high, the grid can become unstable. That's often in evenings on hot summer nights, but particularly in winter when people are turning up the heating, but the sun's gone down and there's not enough wind to meet demand. So we have to rely on gas peaking plants to meet that demand. And not only is that bad for our emission targets, but it can also risk loss of power and damaging our infrastructure. And that's not just because of how high the demand gets, but how fast it rises. So sometimes we need to bring on a huge amount of generation really quickly, and that puts stress on generators because they're more likely to break down when they're turned on suddenly. So next slide. We know that the peaks are only going to grow as we electrify our buildings and appliances. We need to charge more electric vehicles. We have hotter summers and colder winters that need more air conditioning, and we build more data centers in Australia. Also, the impact of adding more renewables and the huge uptake of battery installations are actively changing the profile of the grid. So the grid is definitely in a state of change for the foreseeable future. Next slide, thank you. In terms of solutions, there are some expensive options. So for example, we could use more dirty fuel sources like gas, but that costs our emission reduction targets and it's not a win for the environment. We could build more infrastructure to handle the 5 to 50 hours each year where demand is way too high, but it would take years to build and it costs a lot of money, which in the end shows up on everyone's energy bills. So energy flexibility is a cheaper and faster alternative. And what that means is getting consumers to respond to the grid and change when they use, store, and share their electricity. That way, we ease the pressure during times of peak demand and we take advantage of the cheap, clean, renewable energy when it's being generated. It's also an opportunity for building owners and operators to cut bills and increase revenue, but we'll get to that a little bit later. You may have heard the term before or other similar terms, things like flexible demand, flexing, or grid integrated buildings. So if we drill down a little bit deeper and tie it back to the language that the industry is using, you might be familiar with, there's different types of flexing and different time horizons for each strategy. So it could mean shaping your demand profile over a long period. Maybe that's rescheduling systems or upgrading your infrastructure to flatten your yearly profile. Or it could be a strategy that responds to the grid more dynamically or on a much quicker scale, which is maybe shifting loads by a few days or hours to a period outside of the system's peak. It could be shedding load by drawing from a battery or turning some systems off in the days, hours, minutes, and seconds before peak demand events. Or even more fine-tuned than that, maybe it's shimmying load within the hours, minutes, and seconds of a peak demand event. But we'll get to all of these strategies and what that means for a building and what the best strategies are for a building later. So what is the feasibility study that we're talking about? Last year, we set out to understand how we could and if we should incentivize commercial buildings to be flexible. The study was funded by the Australian government and it involved a really extensive review of Australian literature and international literature, and interviews involving 72 stakeholders from 36 entities across the property, energy, and government sectors. These numbers have already increased as we're continuing to speak with stakeholders and read voraciously. And I just want to, shout out a big thank you to the people that we've already spoken to. And if you're keen to speak with us, please reach out. We'd love to speak with you. So what's the structure of this report? The report outlines what we learned and how we're moving forward. In section 1, we set the context for what energy flexibility is and why it matters. Section 2 explains the role of NABERS in recognizing and encouraging commercial buildings to be flexible and outlines our next steps. Section 3 is where the detail sits. So it covers the strategies that commercial buildings can use to be flexible, and it discusses challenges, drivers, and enablers that we came across during our research. We're going to give you a broad introduction to the report today. So I'm going to hand over to Nova to talk you through the key insights.
Thank you so much, Rachel. We'll go to the next slide. I'm going to talk you through several key insights, and then we'll talk a little bit more about what NABERS is doing in this space. So the first insight from our feasibility study is that energy flexibility can deliver significant benefits. So if we go to the next slide, when we think about this from a building owner or operator perspective, flexing can lower their emissions, it can help them save and make money, and it can help them support a stable grid. And then if we think about this on the next slide, from a system-wide perspective, there are also benefits. So we think about consumers, by being flexible, can deliver substantial grid emissions reductions, economic benefits, and grid reliability. We'll go to the next slide. So we read quite widely for this feasibility study. We listened to a lot of podcasts. We spoke to a lot of people. There are many different figures on trying to quantify the benefits from a system-wide perspective. This is one of them. So it's from IEFA, and it's saying that encouraging consumers to flex could generate over 19 billion in economic benefits by 2040. So the types of benefits they're talking about there are some of the things Rachel mentioned earlier. So not having to build the extra poles and wires, not having to build extra generation, and lower bills. And this quote goes on to say, while improving system reliability and reducing emissions. So all of those things are potential. Every study lists a different number, but they're always big and they're always in the billions. And I think one thing to note here is that most of the figures that are published speak about all buildings, so residential, commercial, and industrial, and there is some research required to understand the impact of commercial buildings. So we'll go to the next slide. Thanks, Regan. The next insight is that there are 3 ways that commercial buildings can be flexible. So if we keep going through the slides, the first thing that they can do is that they can be energy efficient. So if they use electricity when the grid is peaking, so as Rachel said, in summer or in winter, by being energy efficient, they use less electricity during those times, and they help with that grid stress. There are 2 more active things that buildings can do as well. So they can move their loads 2 times when renewables are plentiful away from those peaks. So Rachel talked about shifting and shaping. Some examples of that. Shifting might be moving non-essential tasks out of peaks, and shaping might be a more regular charging of batteries, EVs, hot water systems in the middle of the day. The other things that buildings can do is provide what we've conceptualized as grid stability services. So you might have heard of demand response or FCAS. Using a battery to participate in a VPP is a type of demand response. It fits within that kind of shared definition. And frequency controlled ancillary services to stabilize the grid fits within the shimmy. And we love the shimmy. Only because it's a fun word. Next slide, please, Regan. So what are buildings doing now? Well, we can see that few commercial buildings are doing the active type of flexing, but there are many buildings that are being energy efficient. And, you know, NABERS is really driving this behaviour, and it's a well-established behaviour. But when it comes to moving loads from peaks to times when renewables are plentiful, what's happening there is some early experimentation, but people being really cognizant of the fact that this can be operationally challenging. So, for example, if you preheat or pre-cool your building and it changes the temperatures and the tenants complain, well, that is a big problem for the building owner and operator. The other thing that we're seeing some buildings do is providing those grid stability services that I mentioned before. It's mostly buildings with batteries doing that. And for those two active behaviours, what we're seeing is it's mostly well-resourced buildings with a range of, with a building owners with a range of a portfolio of buildings. They often have sustainability teams, and they're generally working really closely with their energy retailer or their energy service provider. So we'll go to the next slide. Why are there so few buildings flexing right now? Well, the first thing is that we learned a new word when we did this research. You probably know it. The word is nascent. So you know how there's the change adoption curve, and we talk about early adopters. We're kind of even almost before that. So we're in the nascent stage, which means really experimental. And when things are really experimental, you know, by definition, there's not much uptake. But some of the barriers that we're seeing is that some building owners and operators see this as a grid and not a building problem. Other challenges include limited but growing awareness. I don't think there's a week, let alone a day, when we don't become aware of a new article or podcast or conference featuring energy flexibility, particularly since about November last year. Things have just really skyrocketed in that regard. Other challenges are that buildings have competing priorities. They're probably, you know, they might be electrifying, they might be trying to report on their scope 2 emissions. And when something's new, it's generally not a priority for most buildings. There are capability gaps, and that's, you know, for the same reason. The ecosystem around financial returns is still immature, so it can be tricky to figure out how much you can make. Alex Sear is going to talk to us more about that later, which will be excellent. And sometimes those financial returns can be uncertain. There's concerns about tenant comfort and business continuity, which I've alluded to already. There's technology challenges, particularly we hear a lot about batteries and the safety of batteries and where they can be put. And at the moment, there's relatively few environmental, societal, and governance drivers. So we'll go to our final, next slide, which is our final kind of set of insights for this. More buildings will flex as drivers and enablers emerge. So let's talk about what some of those are. We'll go to the next slide, Regan. The business case that I talked about before is strengthening. There's evidence emerging that shows that flexing can be very lucrative. If you think about what the mechanisms are there that help buildings to save or make money, there's time of use tariffs that reward buildings for using their energy in the middle of the day. There's VPP offerings emerging at speed. There's incentives for equipment. And there are these different market mechanisms that are starting to evolve. So SA Power Networks have a flexible demand program, and then there's the New South Wales PDRS, and these are likely to strengthen. All of these things combined are likely to strengthen the business case. So we'll go to the next slide. As I said a minute ago, Alex is going to talk to you more about how buildings can save money and what the value is. And but there are others working on this as well. So the Better Building Partnership are also creating a how to flex guide for buildings, and that speaks to value as part of the information there. Next slide, please. So there's kind of make or save money, and then there's boost your ESG offering. And so let's talk a bit about that. When we spoke to building owners and operators, most of our conversations with them ended towards the end of October last year. They were saying that they didn't see much urgency for NABERS to create energy flexibility metrics. But since then, nearly all of these things that are on this slide have started to emerge. So there's a lot of action and a lot more drivers coming. So let's talk about some of them. The National Construction Code has energy monitoring requirements that have been introduced, and that's for big new buildings. The GHG protocol has proposed some changes around hourly reporting, so it'll be really interesting to see where that goes and how that affects the way that buildings report their emissions. There are time-matched renewable electricity guarantee of origin certificates that have come out. So at the moment, there's a capability for a renewable energy generator to create a REGO, which I'm not going to say it all again, that's the shorthand, a REGO certificate with a 1 hour timestamp on it. We haven't seen any of them yet, but watch this space. And related to that there's this shift in the narrative from I'm 100% renewable energy or I'm using 100% renewable energy to true zero, where true zero is somebody saying, I didn't just use my energy from the grid in the middle of the night when there was no solar and no wind. You can see when I used it, and I used it when renewables are plentiful. So that narrative is emerging. AEMO is working on a demand side statement of opportunities, so that will match the supply side statement of opportunities, and then it's really mapping out the role of consumers in this space. So that I think will be a driver as well to understand what's possible, what's coming, what's needed. And then the Australian government is working on expectations for data centres because, as Rachel said earlier, they're a huge, huge source of demand on the grid. We'll go to the next slide. Thanks, Regan. So most stakeholders believe that NABERS does have a role to play. Let's talk a bit more about that. So next slide. Thank you, Regan. Regan, are you able to move us to the next slide? It may be that I just can't see it.
It should be on an opportunity for neighbours to act. Is anyone else seeing that?
It's just me who can't see it. That's fine. Great. So there's no standard for measuring flexing right now, either in Australia or globally. And when we speak or spoke with policymakers, energy market participants, regulators, industry bodies, and research organisations, they are all telling us that NABERS has an important role to play in the development of energy flexibility in commercial buildings. And when they talk to us, they're talking about NABERS' strong reputation. They're talking about our market reach and our track record for delivering measurable improvements in building performance. So they do think that we are uniquely placed. Based on what we've heard from stakeholders, our role is to ensure that NABERS Energy is fit for purpose to drive decarbonisation towards 2050. Really critical. To make sure that we can help recognise and drive energy flexibility. And finally, which is kind of a build on the second one, provide a trusted, consistent standard to support policy and build industry confidence. So industry can see where we're going, and then policy can be set on that as well. Next slide, please. So our program of work, let's talk a little bit about that. We've just begun a 3-year program of work to recognise and support energy flexibility in commercial buildings. The work is influenced by the findings of our feasibility study, and it's supported by the Australian government, which is excellent. It will involve close collaboration with stakeholders to ensure that NABERS' approach is impactful, practical, credible, and importantly, it's aligned with the operational realities faced by building owners and operators. We have 3 priorities. So the first priority is to review the, we'll go back one slide. The first priority is to review NABERS energy rules so that star ratings don't drop due to flexing. And I'll talk a little bit more about all of these in a minute. The second priority is to co-design and develop metrics that recognise flexing. And the third priority is to strengthen market capability. So we'll go off to the next slide. So our first point of focus is making sure that we look at our rules to ensure that battery losses that are occurred when a battery charges and discharges in service of the grid doesn't reduce people's star ratings. So that piece of work has started. We will be reaching out to stakeholders soon to get their inputs on that piece of work. It's really exciting to see that one happening, and it's a really important piece of work. The next slide. I'll talk a little bit more about co-designing energy flexibility metrics. So I'll just give you a view of what's happening over the next 12 months. We're starting to create these things we're calling proof of concepts. They are metrics that use real building consumption data and grid data, and then a whole lot of assumptions to understand what's possible and what we could measure and what that would look like. So I'll take you through some of the ideas around that in a minute. But we will make sure that once we've got something to show, we will work really closely with our stakeholders to refine each proof of concept so that it's impactful, robust, trusted, all of the words you always hear when you talk to people about NABERS, and aligned and supports building stakeholder goals, because there's no point making something that doesn't support their goals. And then we'll agree on a short list of metrics to take into design and development. Next slide, please. So I'm just going to talk a little bit more about those metrics. So what could those metrics be? Sometimes we work on something and it's very clear what the metric could be, but in this case, it's not. There are many concepts that we're considering and evaluating. We could have a modified renewable energy indicator. So I talked before about REGOs, those time-stamped renewable energy certificates. We could have a renewable energy indicator that had time-stamped REGOs in it, for example. We could create a load shifting indicator that rewards the behavior that encourages buildings to shift their loads towards times when renewables are plentiful. We could have a building peak reduction indicator that's kind of more aligned to the building's own peaks and those peak demand charges. We could create a grid stress indicator. I absolutely love that icon. Again, that's about moving out of those times the grid is stressed or contributing some battery power during those times, potentially. We could update our NABERS Energy Star ratings, but if you've been following us lately, you will know that we're moving our star ratings to an energy metric rather than a metric that looks at emission factors. And so it's unlikely that we would play around with that at this point. What we won't do is but has been suggested by many people, is a stamp that says the building has the capability to load shift or help the grid when it's in stress. And why won't we do that? It's just not a NABERS way of working. We always take real data and we're looking at real performance. So we'll leave that one to others. Next slide, please. So there's lots to consider. Data granularity, when we're thinking about the data that the grid uses and the data that the building uses and the data from the grid, we could be looking at 5 minutes, 30 minutes, 1 hour, and I think different proof of concepts may need a different granularity. And so as we work through our proof of concepts, that's one of the things we're considering. We need to define when renewables are plentiful, because otherwise, how can we say that buildings are moving to those times? Some of the things we're thinking about there is that for the NEM region? Is that for a DNSP? Do we use a static time window? So we say it's from 9 till 2 p.m. How would that work? Or can we use dynamic data? Is that even possible? So those are some of the things we're thinking about there. We are also thinking about defining when the grid is stressed, which is tricky as well. I was on a presentation yesterday. AGL are exploring this. They looked at 9 different counterfactuals. It's really complex and head hurty. We're also wanting to make sure that we understand if a building is using fossil fuels and we factor that in and we don't encourage that. And then the last thing we want to do always with NABERS is fairly compare buildings. And so we have normalization criteria now. We'll start with those and then we can see what we might need to do beyond those. So that's it for this slide. I can talk a little bit about strengthening market capability. So what are we doing here? We want to share this feasibility study widely. So I can't see how many people are on the call right now, but let's have a quick look. Yeah, 136 people. We had another webinar early in the week where there were about 30 people. We're doing Marcoms, so that's really exciting. We also are very likely to support research to quantify the impact of commercial buildings flexing. You'll remember earlier that there's lots of numbers around how much the benefits if all buildings flex, but it'll be really interesting to understand the benefits for commercial buildings. We are and will support energy flexibility capability initiatives. So we helped Alex to create his report. We've been working with BBP, Better Building Partnership, on their guide. We actively already participate in forums and communities of practice where we share learnings, participate in the conversations, and helps us to track developments, which is a really important thing for us to keep doing to make sure that we create something that's sensible and aligned. Next slide, please. So that's it from me today, apart from the Q&A. But if we haven't already spoken with you and you have something that you think you would like to share in this space, we would really love to hear from you, particularly if you're a building owner or operator or a policymaker. But no matter who you are, if you think you've got something to add, please contact Rachel and I, and we'd love to chat with you because we can't make this on our own or it will be bonkers. All right, thanks so much. Rachel, will you introduce Alex?
Yep, over to Alex, who's the Director Energy Sector Lead from ADP Consulting, and he's got some really awesome slides and insights for you.
Thanks, Rachel, and thanks Nova, and thanks NABERS team for helping us get onto this project. Yeah, it's a really exciting space, and there's some great work being done by many parties, and we couldn't have done our work without like a really nice contributing community, because yeah, you can only do these things when a lot of energy and building nerds share a lot of information. So next slide. So the result of our collaboration with NABERS was to produce this paper called Orchestrated Energy. And basically, as opposed to sort of what NABERS did, which was sort of a mapping and an introduction to the space as well as their policy position, we were tasked with creating quite a viable and practical guide about how asset owners would go about it. And so the result of that is this paper, and it sort of steps you through how asset owners can turn their existing buildings into energy assets, and has all types of things from how to flex existing systems, size batteries, and also implement it. But it's a practical guide, and yeah, it's available, so please check it out. A lot of it's involved in this talk, but we've only got about 15 minutes to describe quite a lot. So please, yeah, have a look. And then next slide. So, yeah, so we're in this world at the moment where buildings have many moving components. Essentially, for a building to work optimally, we need sort of, it's got its existing energy profile where it might have tenant loads or lighting or equipment within it. It might have a solar installation. It might have HVAC, which ramps up and down with weather. It could have EV chargers, pools, cold storage. And now we're adding batteries to the mix. And to make this all work together and ramp up and down in an optimized way, a lot of things have to be right, especially if we want it to be a viable and investment opportunity and to be backed for a good business case. And so to do that, we really need to understand a lot of things at once. We need to understand the energy profiles and the solar generation. We need to identify which loads can be shifted or flexed, such as those EV chargers or the HVAC loads or the batteries. We need to be able to size appropriate batteries and minimize their costs. They can blow out if you don't consider things like fire, structure, and the electrical infrastructure. One thing that is really different about making money from flexing is understanding energy bills in the energy market and undertaking informed energy procurement. And this has probably been something historically that designers and also the industry hadn't had to care about too much. But in order to make flexing really sort of profitable and to maximize returns, you've really got to understand the commercial structures. Then you've got to work within the site's limitations, like you can't have a battery that discharges more than a transformer, and also you need to implement the works, the controls, and the commercial arrangements successfully. If we just press the button once. So it can all be really, really complex. And obviously, it's hard to sum up all here. But for the right type of buildings, flexing can cut energy bills by over a third, and batteries can pay for themselves in under 4 years. So there's definitely a lot of value to be made. Next slide. So in order to understand how flexing actually creates value, we've got to first understand how the energy market works and how the ecosystem works. So essentially, if we want electricity at assets and to get to customers, it first gets generated by what we call generators, and they're moving slowly from coal to renewables. At the moment, and then that energy goes through transmission networks, distribution networks, and then gets to the buildings where we use the electricity. And retailers perform a really important task here. They buy and sell electricity off the wholesale market, and they pass on the cost from the transmission and distribution operators, and they offer either fixed price contracts with set rates or variable rates like exposed to the wholesale market, or sometimes some bespoke offers as well. And all of this is overlooked by AEMO, the market operator. Next slide. And with that background, we can start to build some basics about what's occurring in the energy market. Is every 5 minutes, the AEMO wholesale energy market is updated. Basically, it works by supply must equal the demand of electricity. So as the demand for electricity at building goes up, more generators have to come on cost. Another thing we need to understand is that wholesale energy costs equal the wholesale energy price at that 5-minute period times the usage at your building times that time. When the sun shines, energy is cheap, and when solar drops off, the energy price rises. And the reason it does that is to call more generators onto the market. And then price spikes sometimes occur when supply struggles to keep up with demand. And then hit. And we can really see this sort of trend on this graph to the side, where we've mapped the wholesale energy price spikes that occur in different states across a few years. And you can really see that the majority of them are happening in the early evening, with some happening in the early morning as systems start up. And when we've got solar shining, energy is typically cheap and there's not many price spikes, and then it goes up in the evening. And this becomes a really important phenomenon as we start to understand flexing, because you can quickly work out we want to use energy when it's cheap in the middle of the day and not when it's really expensive at 6 p.m. Next slide. The other thing we really need to understand in order to make flexing work is energy bills. And energy bills are given to us by our retailers, and they basically sum up all the costs from the DNSPs, the TNSPs, and the wholesale energy costs from the generators, as well as a number of fixed costs. But we can really separate that energy bill makeup into 3 distinct areas, like fixed costs, peak demand costs, which is about the infrastructure and the size of the connection to a site, and the wholesale energy costs. And so in order to make flexing pay for itself, we really need to think about the bills and what actually gets value and what can actually minimize the cost of electricity. Well, the first way is to minimize energy usage, so sort of a NABERS staple, I guess. Another way is to shed energy when there's a wholesale energy price. We can shape our energy profile throughout the day, so we can use more energy when it's cheaper. Say, for example, generate hot water when the sun is shining, and then maybe use it when the sun's gone down, but not generate more until energy is less. Or we can, with batteries, store energy during the day and then discharge it later at night. Or do shimmy, which I know Nova likes the word, which allows us to basically discharge batteries really quickly and stabilize the grid towards its 50 hertz. Cool. So in order to understand how those two main cost components get made in the energy bills, because they'll be the ones we try to actually reduce by flexing, we've got to be able to visualize that energy profile. So imagine a building that's operating over 3 days, and each day it ramps up in energy usage, then drops down towards nighttime, and then ramps up again and over again. Well, what we do is if we want to calculate the peak demand costs, we need to understand what the peak demand window is. And this is a window set by the distribution networks, in which they don't want you to use lots of electricity because it strains the grid. And that will define your peak demand costs for an entire billing period, which could be a month or up to 12 months, depending on the different state or area you're in. And so the way we work out the peak demand costs is we work out that peak demand, and then during that billing period, and it's times by a set rate. Next one. Meanwhile, the wholesale energy costs, we need to think about our power supply over those 3 days, but we need to track the wholesale energy costs. And for every 5 minutes, we times the wholesale energy cost times the usage at that time to work out the wholesale energy costs. So you can tell the aim here is to reduce the peaks during the peak demand window, and then to reduce the wholesale energy usage, the energy usage during high wholesale rates. Next slide. So flexing, you can probably tell what flexing is going to try and do now, which is imagine a profile now, and this is the original profile. Next graphic. Now, what we can do now is we can look at that profile and go, well, what do we want to do? Well, we've got a number of flexible loads in the buildings, and this is before we add batteries to the mix, which we can change the profile of to make us have a lower bill. EV chargers can turn off during a price spike, chillers can ramp down. Thermal storage, whether chilled water or heating water or domestic hot water, could be charged during the middle of the day when price is low. And this can all be controlled by our building management systems, which already exist. And these building management systems already get data from weather data to help their control. So it's not a big ask for them to take on energy market data to control. Next slide. Oh, next thing. And then lastly, we can have batteries, which can obviously store during cheap times and discharge during more expensive times or the peak demand window. Next. So, so far we've looked at sort of like how a variable price contract would work, where we can do peak demand reduction, but we can also do this wholesale arbitrage, which is a fancy way of just saying playing the wholesale market by ramping up and down at the right times. But a lot of customers are actually on fixed price contracts, which might be long-term ones. And when you've got a fixed price contract, it doesn't pay that well to store money when it's the same price as when you discharge it. So you can really only do your peak demand reduction. However, some customers are going back to their retailers after they've done some flexing, things going, can you offer me a lower fixed price rate? Because the fixed price rate is really the retailer summing up and providing a fixed price energy cost per kilowatt hour instead of a variable market rate, and they take on a risk with that. Next one. And then there's this final option, if energy procurement, which is a fixed price contract, but engaging an aggregator. And aggregators are a bit of a new term, which has come about in the last few years. And aggregators are basically, they aggregate buildings or energy assets together under a virtual power plant. And even though they don't play the wholesale market behind the meter like that first option, what they're able to do is they're able to ramp up and down using these AEMO secondary markets. And the wholesale demand response mechanism allows sort of partial access to that wholesale arbitrage market. FCAS is frequencies, so they get paid for frequency stabilities. There's reliability trader, which is that RERT one, and also they can also get local DNSPs to pay them. And so you can get these revenue streams, and that's something we're seeing more and more of. Next one. Thanks. So We've been looking at this and rolling this out over real assets, and this is a fictitious asset, but it's a combination of a number of assets we've been looking at. So New South Wales Shopping Centre energy bills of $200,000 a year. It's under Ausgrid, which is the DNSP, TNSP, and its peak demand window is 3 to 9 p.m. And this peak demand window is really important because if you have one big spike, it counts for the entire month of your peak demand costs. Next one. So after looking at this, we sized a battery looking at the switchboard, and we worked out that the optimum battery is 200 kilowatts and 400 kilowatt hours, and it cost about 240,000 installed. And we were able to keep, this is a relatively low cost for a battery. And the reason why we were able to do that is because we put it in a position where there was no major fire, structural risk, and also the recently built switchboard at their site didn't need major upgrades. Next one. So with energy procurement options for this type of setup, there could be a fixed price contract model, which might only pay for itself in 13 years because we could only get peak demand reduction. Next one. Fixed price contract model with an aggregator engaged. That one, you could get the peak demand reduction, but you could also get these secondary market streams. Obviously, the aggregator will take a bit of fee for their services, and that could pay back in just under 5 years. And the next one is the fully wholesale exposed behind the meter strategy. So this is where we play the market ourselves with our own controls and everything, and that could pay back in under 4 years for some assets. So really, there's different risk profiles and there's different existing conditions, but there's definitely viability for definitely some good projects. So next slide. So which buildings actually make great opportunities to flex? Well, the ones we normally look at are ones with larger electrical loads. There's operational efficiencies in getting these set up because there's complexities and there's education. If buildings have operation that extends into the early evening, that's really beneficial because it allows us to store energy during the middle of the day and then offset energy usage in the evening, and that's really valuable. Larger solar arrays can give opportunities for batteries to store for free, and they can also reduce energy profiles coming through the gate meter so that you can charge your batteries. It's quite a complex point, but some people understand that nuance. Different DNSPs in different states actually provide incentives for flexing, and certain states which are more advanced in their solar rollout, such as New South Wales, Queensland, and South Australia, actually have better paybacks. Different states have different incentives. Embedded networks allow larger loads for which energy can be stored and then discharged. Retail shopping centres, for example, have sometimes sort of food and beverage tenants which extend into the evenings. They're a good indicator of those. And also if you've got an energy usage which has short, sharp, intermittent peaks, which are defining your peak demand. So you can really take them out with either control or a battery. We've talked about sort of how to lower battery installation costs, and fire, structural and electrical upgrades all need to be avoided where possible. And the good candidates to get started are shopping centres, data centres, airports, hospitals, hotels. And really we're seeing there's a lot of asset classes where you can make money through flexing. Next slide. And there's more in the paper. So yeah, there's only so much you can say in 14, 15 minutes, but there's more on policies and incentives, battery sizing, methodologies, co-locating batteries at DCs, why that's a good idea, quite topical at the moment, additional energy market insights, some control strategies you could roll out on Flex, and a lot more. And there's a QR code there for people who want to learn a bit more about the topic. So thank you, Rachel and Nova.
Great. Thanks, Alex. Now we are almost at time, and so I just want to make sure that I have the opportunity to put our last slide up on the screen, Regan, if you're able to do so. We just have the link and the QR code, and this will go out, but if you're on a phone and you feel like just quickly being sent to our website for where we have published our report, you can do so. So yes, thank you, Regan. Yeah, so the report is published on our website. Please, we encourage you to download it and give it a read. It's only 60 pages, which, for all the reading I've done in Flex in the last few months is quite short. And please, reach out as we're going through the proof of concept phase of the project. We really would love to talk with more building owners, policymakers, and anyone in this space and anyone who's interested. So please reach out to Nova or myself, or just the NABERS general email. We can filter you through to us. And otherwise, thank you very much for your time. And if we didn't get to your answers, we can reach out afterwards, or your questions, sorry.